Where I left off, I just want to finish off the constructor initialization. So there's multiple ways. Constructors are so commonly used for initializing variables within the class that there's actually a special way that you can actually initialize members. So I want to show you a couple of the ways that you can do this. So by default, the top line is kind of like the common, like one of the more common ways, which is just do the initialization inside the function implementation. There's another way you can do this, though, which is called member initialization. It's called a member initialization list. And you basically, this is used to assign a value that's been passed in to a member variable. It's so commonly used that they actually created something that lets you do this. Basically, to do this, you have your constructor and your arguments for your function. You put a colon in, the name of the member variable you want to initialize, and the value you want to initialize it to. And if you do this, this will get initialized before anything inside the curly braces will get called. And more commonly, instead of splitting it up with doing both, you do this right here. This right here, which is the member initialization list for using the variables like that, is so common that it's like pretty much like if your class only has data members inside of it, like this is typically what your constructor looks like. This is very common in this case. So just for example, so circle here has a member which is called radius, and it has a constructor which takes one argument for double, and it has a member initialization list which is a colon radius and passes in the argument r into that member variable. And all that means is that instead of doing this inside the function, you do it in line inside the constructor. So let me show you. So I can do this here. Instead of writing this height like this, typically what you do is you write height, and actually you do it like this. Like this. And if I were to have multiple variables like b, you would do width like this. If I could just put this on one line. I'm just showing you how we do it on Overwatch, but this is typically how you write your constructor. So you have a colon, you have a member variable you want to initialize. So in this case, I'm initializing height to a, and then you have a comma, and then you have another variable you want to initialize. And this is important because whenever you're calling this constructor, the order of operations is it does the member initialization list first, and then it does whatever's inside the curly braces here. And it's kind of also a personal preference thing. For the most part, it shouldn't matter, but the intent is that you're doing this a lot. Like we have like things like our player object or like our stats or our health components all have like constructor initialization lists that look like this, but they have a lot more in them. You know, they might have like HP, I don't know, is equal to X, and you know, armor, I don't know, Y, and then shields, Z. And if you want to, you can even just do this with a default constructor too. Like you don't have to use arguments, like you can initialize them like this. Put zeros in for all these. And by doing it this way, it kind of just saves you time. Like this is equivalent to me doing this. But it's also a little bit more foolproof, and like you don't have to worry about writing it down here. You don't have to worry about writing assignment statements. It's only used for initializing variables, and this is a little bit more common. The convention is a little bit more common to do this. So you can see here we have radius r being passed in, and we have a cylinder. Oops. So we have two classes here. We have a circle class, which is just a standard circle class with a radius. We have a cylinder, and this is an example of us having a class within a class that has a height, as well as a circle, which defines what the base of a cylinder is, right? A cylinder is just a circle with a height associated with it. So when you're creating a cylinder, you pass in what you want the radius to be as well as what you want the height to be. And so you can see here in the member initialization list, the first thing it does is initialize the circle, which is called base, with the radius. which then calls up to here and initializes the radius up top. And then height is just a double and initializes that to height. And if you look at how it calculates the volume here, notice it's calling a function area on the circle and then multiplying it by height, and that's going to be the volume of the circle. So you can also use pointers, as I kind of mentioned. So if we go back to the example of a rectangle, objects can be pointers, just like any other object can be. So this is an example of declaring a rectangle as a pointer. If you're using an object as a pointer, however, instead of using the dot operator, remember that you have to use the arrow operator to reference them. And this right here, this slide, is going to be a review of what you can use pointers with. Like, remember, there's several different operators associated with pointers, one of which is the asterisk, which denotes that you want to use a pointer. Then you have the ampersand, which goes in front of a variable to get you the memory address of that variable, which you can then use to assign to a pointer here. Whenever you're accessing an object that is a pointer and you want to get a member of that object, you have to use the arrow operator. If you're using a non-pointer, then you use the dot operator instead. So let me just go over this table here and explain each of these things, because they're all important. These are all, this is the trickiest part of what kind of like you have to remember syntax-wise. The first row here, remember, you have an asterisk in front of a variable. It can mean one of two things. This asterisk x can mean either, I'm going to go down here, one of two things. I either have this. What does that asterisk mean in this case? Anyone know?
Pointing to an integer.
X is a pointer to an integer, correct. And if I say x equals new int, give it 42, this means something different than this, right? Yeah. This right here means give me the value of what's stored at the address at x. Remember, this is also different than... What is the difference between those two? What will the first line print? And what will the second line print?
The memory address.
The first line will print the memory address of x. The second one will print what's the value, right? Okay. So then here, going back to the slide, that's what this is. This gives what's the value that's stored at x. If you put an ampersand in front of x, it'll tell you what the address of that variable is, which oftentimes gets used to assign it to a pointer. These two are basically the same thing. The only difference is that the first one is used when you have an object that's not a pointer. The second one is the arrow operator, which is used when you have a pointer and you want to get access to it. This right here is exactly the same as doing this right here. Okay? These two are the same because this says, hey, get me y, which belongs to which is a member of the pointer x. This says, hey, give me the value of x, get me what's stored at x, and then get me y from that. But I know that this is not a pointer anymore because I've used this little asterisk in front of it, so you can use a dot. You actually will see this occasionally here, like that. So keep in mind this is not like super uncommon. And then the last three are just, this is how you access elements in an array, right? Okay, so to wrap things up, here's kind of a summary. So classes are not only defined with the keyword class, but you can use the keyword struct. Structs and classes are identical. The only difference is that structs are public by default, while classes are private by default. For all other purposes, for everything else you're about to learn in this class or forever in C++, understand that structs and classes are exactly the same, except for the fact that the modifiers are different. Everything that a class can do, a struct can do. You can do exactly the same thing. Doesn't matter. You might as well just do a replacement. Yeah.
It's kind of silly to do it this way. Is there such thing as a private struct?
Mm-hmm. Yep, you can do that. Oftentimes, you'll do that if you already have a structure. It's like, oh, well, all these things are public before, but I want this one variable to be private. You could change it to be a class. You could change the name of it, which would then change everything on it to be private by default. oftentimes you'll just change the scope of it. Again, the reason why you would pick one over the other is kind of personal preference. For me, I use structs when I want all the variables to be public by default, but also usually when structs are used, they're used for like small numbers of member variables. Just because it's kind of like, oh, well, it's kind of a small set of things. I don't have a ton of functionality here, while classes are more for like formal, like larger objects that you want to represent. It doesn't mean that you can't use structs for classes and classes for structs, though. So there's another keyword called a union, which is something that is special, and we're not really going to use it a lot, but you guys should know that it exists. And unions are the same as structs and class. However, unions only store one data member at a time. They can declare member functions, but what this means is that if I have a union and I declare 4 data members inside of it, so an int, like I declare like for a stat, I have like, you can declare, instead of a struct for a stat, which has like current, max, average. This has 3 members in it, so it takes up 4, 8, 12 bytes. If you convert this to a union instead, only 4 bytes will be used, so it'll only represent one data member at a time. And this is often used in a case where you have something that is stored in something like, oh, I have 64 bytes. I have something that's like kind of like a very generic structure that I don't care what's in it, but it can be used to represent one of these 3. And it's a very kind of special case usage. And I would say that most oftentimes you don't need it, but just keep in mind, if you have union, only one of these variables can be used at a time, which means this thing can only store one of these. So if I have my stat here, I'm going to create a stat called test union, and I do test union, and I set the current equal to 42, but then I cout test union dot max, it's going to print out 42 here. All 3 of these variables that live inside that stat all occupy the same space in memory. Okay? That's why it's called a union. They all are unions. They're all combined into one. Okay. All right, so let's go over the lab. Questions first. Anything about this stuff? Member initialization list. Okay, so here's what I want you guys to do. So I give you guys a link to a web page, which is kind of a reminder on how classes work, and at the top. And I put this up on Zool, in SDVA213. I kind of want you to write some classes, and we're going to do more class writing next week. We're going to do virtual inheritance. First thing is I just want you guys to write a circle class. Okay? A circle has a radius, and a circle has a couple of member functions to get the diameter and the circumference. Okay? I want you to make 2 circles and then print out the diameter and the circumference of both circles. Next, I want you to write a class that describes a Pokemon. It has 4 members, which is a name, attack, defense, and HP. And I want you to create a couple of functions that print out the name, HP, attack, and defense, as well as another function called getCPValue, which is kind of like Pokemon Go style. I don't know who's playing Pokemon Go. Is anyone playing it? I was playing it, and I kind of stopped. I don't know.
Yeah, I play like when I'm bored.
Yeah.
5 minutes.
Yeah, it's kind of interesting. Apparently, there's like someone data mined it, and they found that there's supposedly a Master Ball in it, and there's supposedly legendary Pokemon somewhere in the world.
Legendary Pokemon have no catch rate, so you have to use a Master
Yeah.
Ball.
If that's in the data mine, it has been released because there's only things that only 6 are accessible.
Yeah. Who knows where they are? So I want you guys to write a function that says getCPValue, which basically is just attack times the square root of defense. Once a class is written, I want you to create 3 Pokemon of your choice. I want you to initialize each Pokemon using set values and then call print info on each. Once you do that, I want you to remove set radius and set values, and instead I want you to write constructors for both classes that do the same things as those functions. And then for number 4 and 5, number 4 I want you to use pointers instead of using just standard objects to create your circles in your Pokemon using new and delete operators to create and destroy them. And finally, I want you to change the 3 Pokemon that you created to use an array of Pokemon instead of 3 separate variables. Okay? Same exact functionality, except you're going to have to use a loop to go over them. All right? Okay. So that's it. So whatever you don't get done will be handed in for homework. This is lab add homework. So you guys can start on it now, and you have pretty much an hour and 15 minutes for the rest of the class to work on it.
So